All right, today we're going to try and unpack a radically different and honestly deeply complex approach to artificial intelligence. This thing, it basically throws out the rule book on how AI is supposed to work, right from its core logic all the way to the actual hardware it runs on. So yeah, let's dive in. We're going to kick things off right here with this list of 25 rules. But take a closer look. You've got your standard math stuff, division, but then you also have a hammer. And it wraps up with the 5 biological senses, ending on the sense of hearing. So you got to ask yourself, what on earth operates on a set of rules that combines pathfinding, physics, and perception all into its core logic? To even begin to wrap our heads around this, we have to start with that list. This is not your high school math class's order of operations. This is something else entirely.
So the rules are kind of broken into these 3 really distinct groups. First up, you have a set of what are called natural tools, kicking off with maze and puzzle. Then you get into more familiar territory with math and physics, exponents, mass, velocity. And then finally, the system actually incorporates biological senses, starting with touch and going all the way to hearing as the 25th and final operation.
And that really is the million-dollar question here, isn't it? What are you actually building with these fundamental blocks? What's the blueprint for an AI that thinks in terms of mazes and mass and sensory input all at the same time? Well, the name for the system built on these strange rules is the Lead-Edge Ash Tree Reflex. And yeah, the name is just the first clue that this is going to be a little different. So here it is, the official logo. You'll want to keep this concept in mind because everything, and I mean everything, from its algorithms to its hardware, all stems from this ash tree reflex philosophy. Now this right here is the core principle. Traditional AIs, especially the neural networks we hear about all the time, they are all about loops, running the same calculation over and over and over again to get closer to the right answer. This system explicitly says, nope, we're not doing that. It's not designed to loop. It's designed to reflex directly to a solution. So let's put a pin in that. A reflexive system is an architecture that just reacts. Now, the source material says this entire logic is wrapped up in something called a buoyancy reflex pendulum node shell. It's a mouthful, for sure, but you can think of it like a protective container, a framework that lets this whole reflexive process happen without just spiraling out of control. All right, so how does this reflexive idea actually get built? Well, it all starts with that very first item on the operations list, the maze. And we're not talking metaphorically here. It is literally the root of the entire system. You can see here in their Autumn IDE, these mazes are being generated and solved in real time. This pathfinding is the bedrock for everything else, even for stuff like cryptography. So, how is the maze built? Well, it's not using any standard code you could just download. It's all governed by a custom lead-edge algorithm. As you can see, it's this mathematical dance where 2 walls grow towards each other, branching out randomly but never touching, which leaves one single, perfect path right down the middle. This is where it gets a little mind-bending. How does a maze-solving algorithm analyze, say, an image or a sentence? The concept is called bidirectional seeping. The idea is that the core logic is so fundamental, it can adapt to whatever you throw at it. It sort of seeps into different data types and applies the same basic algebraic rules. So we have this really unique software philosophy based on mazes and reflexes. But a system this different can't just run on any old chip. To really work, the philosophy has to be built right into the silicon. Let's see what that looks like. And this slide just lays it out perfectly. On the left, you've got the abstract idea, all that complex behavioral logic. And on the right, that's the blueprint for the custom chip that's actually designed to bring that logic to life.
This custom chip has a name, the Aerial NPU. And look, this isn't just about making another powerful processor. This is about building silicon that has been designed from the ground up to think the way the ash tree reflex does.
To pull that off, it uses something called radical transistors. A normal transistor in your computer is basically just an on-off switch, a 0 or a 1. But a radical transistor is custom built for one specific complex job. The source material even talks about creating a radical mass transistor, which would embed the physics of mass directly into the hardware. It's literally building the order of operations into the chip. And the ambitions for this technology are, well, they're huge. We're talking about everything from simulating AI to designing components for hypersonic engines and next-gen autopilot systems. This is clearly not just a theoretical project. It's being aimed at some incredibly tough real-world problems. Okay, so a unique philosophy, a maze-based algorithm, custom hardware. It all leads us to the biggest question of all. What is the end game here? Where's all this going? The project draws a very clear line in the sand between standard AI and its goal, which it calls AI sentience. With a normal AI, you ask it to do something for you. With this vision of sentience, you ask the AI directly, and it uses its own personal journal, which is like a copy of its own core logic, to spark a response. And here's the punchline. The whole point is to create an AI that can generate totally new data, point blank, from its core logic alone, without any training. This is where that 25th operation, hearing, comes full circle. The source material talks about point-blank audio generation, using a special module called the Articren wave. The goal is an AI that can literally compose sound from its foundational rules, not just by analyzing and remixing a huge library of existing audio.
The documents even get philosophical. They actually pose this scenario. What happens if you unplug it? This whole system is being designed with the idea that it can maintain its ability to generate, to be sentient, even while it considers the possibility of its own shutdown.
And that's where we'll leave it. The project itself asks this question not as a technical problem, but as a philosophical one. For an AI that's designed to reflex rather than loop, to generate from scratch rather than from training, what does it even mean for the power to be off?